I will report on a series of discussions we had with Bayer Healthcare and BASF, and also, of course, the BAuA, where we were looking for how to describe this. So in the end, we ended up with a standardized application for authorization, because everything like simplified and streamlined was already taken by other aspects of modifications. I gave it as a kind of title to keep it easy, the bare necessities. Those of you who know the Disney classics may remember that the song actually continues with, "Forget your worries." Well, unfortunately, that's not something I can promise from this presentation. But the background of this is, in 2011, several aprotic solvents came on the candidate list. And one of them was ethylene dichloride. That's a carcinogen 1B. And most of these solvents, as also these EDC, are process solvents. So they do not end up in the final product. They are distilled off somewhere along the route and recycled. First, we had the usual discussions where industry came to us and said, "Can you help us to get out of this?" No, we can't. So for better or worse, the process continued, and EDC ended up on Annex 14 and has now a sunset date in 2017. We understood from our partners in industry that they consider this process of going to write an authorization as rather cumbersome, time-consuming, and also fuzzy and uncertain in the outcome. And their management has a very clear message: go and make this work, and do not come back and say you failed. So, supported by the German government, some ministries in Germany, they told us, well, why don't you talk to, in this case, Bayer and BASF, also invite the VCI, so the German Association of Chemical Industries, to see if you talk through this, can you reduce it really to kind of standardized example? Because in this case, the ethylene dichloride may be not such a difficult case. And if you come up with some general principles and experiences here, we can maybe generalize this also for other people to use, not just these two applicants. So during 2014, we had in total 5 meetings discussing this, where we went through the different aspects of an authorization application for authorization, which is process description, exposure data, where we focused from the BAuA point of view very much on asking, what data do you already have? Because you have done that for other purposes, so that you can use this for this application. Are there gaps in this where you need to measure again or need refinement? And what are the essentials to build your case? So basically, we did the talking, industry did the work. We gave some advice how we thought they should structure this better, as far as we could perceive the mind of ECHA, what ECHA would like to see. And I think I can conclude that we had a very fruitful cooperation. There were no lawyers present, which always helps in the discussion. And it helped us, I think, to discover the essentials. And I think in the end, there was a general feeling, at least for these particular cases, it's not as difficult as it looked at the beginning. So the working example, which Mr. Hoffmann will present in a moment, it's EDC as an example for a carcinogen without threshold, and Bayer uses this solvent as a process solvent to produce a medical agent, which I learned is called an API, an active pharmaceutical ingredient, and BASF is using it in a completely different type of process as an extraction solvent to prepare a high purity chemical, which is then used in another process. In both cases, they are dealing with closed process, a closed system. So the solvent does not go out to the customer, it is not part of the final product. And both processes have in common, they're very critical. The quality of the end product depends on the purity. And even with subtle changes in the product, where a normal chemist would maybe consider those to be acceptable, will change the final product in a way that it cannot be used or it needs substantial requalifications. So we hope that in the end we will show in this presentation what we selected as the bare necessities for the authorization application. And we think with some thinking, these findings can also be generalized to other substances, especially those which are used as process solvents, like in this case. So, Mr. Hoffmann, you can continue.
Thank you. Good morning. My name is Martin Hoffmann. I'm working at BAuA Healthcare. I'm leading a team which is responsible for the global GHS implementation worldwide and also for the REACH implementation. And I'm the happy guy who reports all this program to the management, to the board. So we met each other several times with the BAuA and the other companies, and we had 3 essential meetings. Means one time we discussed exposure, one time we discussed the AOA, and one time we discussed the ZER, and this is also the structure from our presentation. So I start now with the exposure. The BAuA asked us to present our exposure in an understandable and transparent way. That's why we delivered a lot of process description, we delivered flow charts, we delivered pictures, and also we delivered measurements. We put them together in Excel sheets. We combined our measurements with the pictures, and also we provided our risk management options, and also we provided how many workers are exposed and how high the exposure is. So I forgot to push the button. Sorry for this. So we have undertaken a lot to demonstrate that we reach a very the lowest exposure, the lowest possible exposure. And we think if we are doing this, that we have a compelling argument for getting a low revenue period with proving that we have reduced our exposure. So here's an example. So we showed also our normal operation, but we presented also measurements in so-called critical areas. Critical areas are sampling, filling, and here's also an example for the sampling. Sampling, we are working in a very corrosive environment, and that's why we have here a rather high exposure. And of course, we initiated countermeasures. We combined these kind of tables with pictures, descriptions, flowcharts, explaining the third party, in this case the BAuA, that we are working in a closed system. And also we see it here on the right side as a kind of flow chart. Here we see also a picture for sampling. This is a standard tool that we implemented, but because we are working in this kind of corrosive environment, it was difficult to handle. Sometimes the container blocked, and this was the reason why we have had higher exposure. And meanwhile, we replaced this kind of tool with another tool, and we achieved a lower exposure, and we can prove it. So this is so we discussed this exposure, and when we started with the project, the RAC reference value was not available. So there was a discussion how to evaluate the exposure, and we are 2 German companies, the German Association, German authorities. That's why it's not surprising that we used a German model. So what we have done is we have taken a value coming from the registration dossier, we combined it with the cancer risk, and according to the German approach, we call it tolerable risk threshold, and we have an acceptable risk threshold. And why do I like this kind of picture? I've taken this slide and I went to the production site. And I explained these guys there working the production site that we are in some cases we are in the red area. And I explained these guys as well, if you want to continue with your production, if you want to defend your workplaces, you have to achieve the green area. So please release budget. Please initiate measures that we reach a very low exposure. And you have also to know these production sites are always under pressure, and there's always a production site in the world who can do it cheaper. So we get our budget and we implemented these kind of measurements, this investment in containment. Coming now to the second meeting, this was the AOA, the analysis of alternatives. So if you consider alternatives, you have to consider substances, you have to consider process changes, you also have to consider new technologies. And this example is coming from the guideline 120 pages. I read them all. And we started with a kind of description of the function. I think this is a good advice, a good hint, because if you can provide a very detailed description of the tasks of your function, then it is easier to evaluate all the possible alternatives. You can easier evaluate whether an alternative could work or not, given that you have a very detailed description of the tasks of your substance. Here's an example. It's only one example which we showed during our meetings. So on the right side, you can see, from my side, it is the left side, we have described the tasks and the properties of the substance. We can see immediately that we have a high challenge regarding solubility. So it has to react with one substance, with another substance, and then with another substance again. We are working in a very aggressive environment. We have a high boiling point. We have high requirements regarding recycling. And so here it is, for everybody, understandable that it is really difficult to find a substitute here. And I can say that because since years we are investing in R&D for finding a substitute, and it doesn't work. Here we put different cases together, cases from BASF and cases from BAuA Healthcare. So the substance 2 case is the BAuA Healthcare, is one BAuA Healthcare case. Here we found something which technically works. But we have a loss of more than 30% in our API, in our drug harvest, more than 30%. And we are considering here a high volume and low price medical drug. So 30% loss of harvest means it is, under economic point of view, it is not feasible. Substance 4 is something which represent BASF. They have, of course, also something which could work, but here the raw material is much more expensive, and all in all, the end price from the product is also very expensive as well, and I think it will not work in the market. We have another interesting example. This is here technology 2. Here BASF said, yes, there is a technical available, but it is used from the competitor. And the willingness of the competitor to sell this kind of license to us is very low. So difficult now to evaluate whether it is available or not. So here we are now coming to the SEA, and there was no time for me anymore to read whole the SEA guideline. So I helped myself with a presentation from the ECHA 2012, where I found this kind of slides. And I think it is very helpful because 2 years ago, I explained to my management that the SEA is very complicated, that it will cost millions of euros, and that we have to hire a lot of consultants to conduct this kind of SEA. And I think with this kind of picture, we have now a better approach. I only have to explain that the green square overweight the red rectangle. The green square describes our non-use scenario. And we, as pharmaceutical company, have a very good non-use, a very convincing non-use scenario, because if we stop API production, the product will not be available on the market. We will see a kind of shortage of the product supply of this kind of pharmaceutical. Because if we stop, our competitors can't close the gap. So the pharmaceutical we'll see a kind of shortage. So we can't guarantee the supply with this medical anymore. Furthermore, some people may prefer our API. It depends, I can't say that, but this could be the case as well. So I think this is a really, we can demonstrate without monetizing that we have here a very strong impact on the society. Furthermore, we can demonstrate a high loss of profit. We have contract penalties because we have long-running contracts with medical departments from other countries. And if we can't deliver anymore, we have to pay a lot of fees. And of course, we have effects on our suppliers because there are some suppliers which have a tailored production to our API production. On the other hand, we can calculate the red rectangle very precise because we have a small number of workers who are working in a closed system, with a closed system, very low exposure. I tried to monetize this. And I found also a chapter in the SEA guideline where you can calculate, I do not know whether it is allowed, but we did it, where you can calculate a worker's life with 1 million euro. So given that this works, I can calculate the exposure risk in a simple way. I made the assumption that 8 workers are working with our substance, and I make really the assumption that they will die all, and then it costs 8 or 16 million euros. It depends whether you calculate 1 million or 2 million with a worker's life. So this kind of calculation is easy, and compared to the loss of profit, to the impact of society, this is always low. So that means the green square will, in this case, overweight the red rectangle. We have to say that this kind of approach only works if you prove really that the exposure is very low, that you have everything undertaken to guarantee a very low exposure. This is prerequisite. So then I was asked also to provide a hypothetical substitution plan, because we don't have an alternative, so we can't substitute, but we developed one. So again, I want to repeat the circumstances. We have low risk, low exposure. We have a high socio-economic benefit. We have no alternative, and it is not mentioned here on the slide. We are working in a very high regulatory environment. Everything is regulated by FDA, by GMP, so there are a lot of regulation, and furthermore, the chemical is not present in the final product. So this is why I'm asking for a long review period. Because, and I'm wondering that this was not mentioned, this authorization thing affects huge investments of our industry, huge investments. I'm speaking about billions of euros. And if I would return to my management saying that we got 7 years or 10 years, this will create a lot of uncertainty. For this will create a lot of uncertainty, and I will not feel comfortable with this kind of message. So, summary. We have showed that we can do a kind of standardization with 2 examples. I think we have shown that presenting exposure in a transparent and understandable way is possible. We think very helpful is to get RAC reference values in time so that we can show where the exposure is and whether we have to invest more in containment. I think work should be done in a structured approach of the AOA, because the AOA is the heart from the dossier, and here we need a structured approach. Maybe in future best practice examples will be helpful. We should stick to our arguments in the SEA as pharmaceutical industry. We should stick to our compelling business case, and we do not want to produce more paper than required, because I think that only will dilute. And This means time up?
Yeah, just finishing.
Okay. But this is the last slide. So I think we have some nice steps for the beginning, explaining that the standardization is possible, and perhaps we have also some advices for the expected learning curve regarding review periods. Thank you.
Thank you.